This video will help prepare you for finding more difficult polynomial functions given some zeros. So basically, we're going to start off by just looking at a problem we've done before. In number one, you have this polynomial function, and we're going to factor it completely by using our graph. So I've actually already graphed this for us. You can type this into your calculator if you'd like, but it looks something like this. Okay, it is a quartic function. And it looks like it just has 3 intersection points, but if you check, this one is actually bouncing here. And if you do your second trace 5 and find your intersection points here, you should get a -2, 0, a 4, 0, and a 7, 0. So, if we were to factor this completely, these are the roots. We have a -2, which means originally when we had it factored it was x plus 2. It will be squared since this is bouncing. With a root of 4, we have x minus 4. And with a root of 7, we have, squeeze that right there, x minus 7. So notice you have 1, 2, 3, 4 solutions, just like your degree here of 4. So now, if I tell you that the roots are 4, -5, and 2, you should be able to write a polynomial function for me. So basically, we're just going to go backwards. You're given these answers, then you will write your factored form, and then we're going to have to FOIL the whole thing out and get something like this as our final answer. It's not difficult, it just takes some work. Okay, so always start out with your f of x equals, if your root is at 4, or your 0 at 4, originally you would have x minus 4. If your 0 is at -5, you would have an x plus 5. And at 2, an x minus 2. And now we're just going to FOIL this out. So I'll FOIL this first. And when you do that, you should get x squared plus x minus 20. And now we have to FOIL again with the x minus 2. So we'll get x cubed minus 2x squared plus x squared minus 2x minus 20x plus 40. And we'll just combine like terms to get our final answer. X cubed minus x squared minus 22x plus 40. And this is your answer. Okay, it has real coefficients, the given zeros, the leading coefficient is 1. Okay, so I mean, you could have a polynomial function with these roots where you had a 2 in front, but we're going with the simplest case that has these zeros. So as you know, sometimes you have roots that are imaginary. And when you have imaginary roots, for example a 2i, it always comes in pairs. Because in order to get an I, you're taking the square root of a negative. And when you take the square root of both sides, you always have a plus or minus. So whether you have a 2i here or a -2i, you actually have both. Okay, you have to. Okay, because when you take that square root, you always have that plus or minus. You'll have 2 imaginary roots. So the 4 you're just going to treat like normal. It'll be an x minus 4. Now with the 2i, you have 2 options. The first is just to say, hey, when the root is 2i, you must have an minus 2i. And when it's -2i, you must have a plus 2i. And then FOIL this out. Okay, so let's FOIL this part here first. You would have, we'll do this off to the side, x squared plus 2ix minus 2ix minus 4i squared. So these cancel, but remember I squared is -1, so this really changed to x squared plus 4. So that's what you're going to be FOILing. X minus 4 times x squared plus 4. Now, there is another way to get this x squared plus 4, which some people prefer because it doesn't involve foiling. All you're going to do is set x equal to 2i, which is what you were given. We want to get rid of that I, so we're going to square both sides. 2 squared is 4, I squared. So x squared is equal to 4 times -1 is -4, and then just add that -4. So x squared plus 4 equals 0. Notice that this x squared plus 4 is what you get when you FOIL it out. Some people just kind of naturally see it too, and they don't really do either of these methods. They just are able to do in their heads that you're going to have an x squared plus 4. Okay. Regardless, you still need to FOIL at the end. So we'll have x cubed plus 4x minus 4x squared minus 16, and always make sure you are in descending order. So we're going to have to reorder this. And this will be your answer. Okay, so this, if you were to graph it and do synthetic division, you would find it would have roots at 4 as well as plus and minus 2i. All right, let's try one more. All right, so 5 and -3i. Again, this is really both positive and -3i. They have to come in pairs. If your 0 is 5, that's an x minus 5. You can set x equal to -3i. Square both sides. -3 squared is 9i squared. X squared equals -9. X squared plus 9 equals 0. That is what you're going to multiply to this. The other option is to do x plus 3i, x minus 3i, and that will FOIL to the x squared plus 9. Okay. And like I said, some people just kind of figure it out in their head, because if you get a plus or minus 3i as your answer, that means originally next to your x squared you needed to have a positive number, because you need to subtract it over, and that's why it becomes imaginary, because it's negative. So, I mean, some people, like I said, just can go straight to this. Now we'll go ahead and we will FOIL x cubed plus 9x minus 5x squared minus 45, and reorder everything. So it is in descending order. Okay, and there you go. So these are kind of the simpler examples. In class, we are going to do one where your root is 4 plus I, so something a little more complicated, and so we will see that tomorrow. All right, have a great day.